Hey y'all, I'm Austin. I'm the CEO, co-founder of Focus Labs, and I've been playing a ton with LLMs and hacking on them, hacking with them, using the OpenAI APIs, all that kind of stuff. Um, and I've also been really diving into social media and trying to like share out some of the stuff that we learn and do at Focused. And so I thought it'd be really fun um, to show you a tool I built. One of the least favorite things I have is, or one of the least favorite things I do is when I do these YouTube videos, I have to like think of clever titles and descriptions and chapters and all that other kind of stuff. And I built a simple tool that uses OpenAI's Whisper API to pull in a video that I've recorded and then transcribe it, give it to an LLM RAG, and then allows me to ask questions of it, use the LLM to generate descriptions, and finally, like use those in my YouTube videos. I can do like descriptions, titles, chapters, all that kind of stuff. That'd be fun to just like build this again with you all, show you how we build or kind of I would build this software. I'm not going to do a big TDD style like, production app. This is just a tool I built for myself. But I think it's kind of fun to see how easy it is to build AI applications using LangChain and especially with LCEL, which is LangChain's new LangChain expression language. It's like a non-class based, more pipeline oriented kind of DSL or language for creating pipelines of prompts into LLMs. So I'm gonna live code this. Hopefully it's not terrible, and you guys all learn something, and it's fun. Feel free to like comment, ask questions, anything like that. So I have a generic project. There's nothing here besides the OpenAI API key in another file, and then like an empty poetry. So I know we're gonna use LangChain, so let's just install it. So we'll poetry add LangChain, and that'll install LangChain for us, just so we can start to use some of the auto completion that PyCharm gives us. So I have this file. This file is my video, and so I need to get that up into the Whisper API, and luckily LangChain gives us some tools to do that. So I have a file system blob loader, which is a simple file, like tool to load a blob off the file system. The signature is pretty easy. You can just pass a file in. I like using non-positional arguments, just like kind of who I am. And then now we have our blob loaded up. So I think this is fine. We can call this like a blob loader or system blob loader. And then we need to get this into the Whisper API. So LangChain also offers this generic loader, which allows two loaders to interact, or a loader and a parser to interact. And so what we'll do that, and this will allow us to eventually get a transcript in the form of documents from our video that comes out of the Whisper API. So then we can cut that up into documents, store it in a vector store, and then interact with it like any other LLM. So if I use a generic loader, I can pass in my system blob loader, and I also want to use the OpenAI Whisper parser. The OpenAI Whisper parser is another thing that comes from LangChain. Those two things together end up, what will happen here is this loader will get returned a loader that we can then load our documents through Whisper, or I can load this blob through Whisper and then get our documents. So I do need to pass in an API key, so let's do that. And actually the cool thing is we can already look at what's happening. So if I just print out my loader.load, we should see, and it might take a second because this is not a tiny file, this try to run, and we didn't get anything good. So let's pull this out and see why that didn't work. So let's look here. No module named OpenAI. So of course LangChain doesn't come with OpenAI, so let's install it. So we just need to use poetry add OpenAI, and that should give us what we need for the transitive dependencies that LangChain needs. And if I run this again, Let's see what we get now. So if I look at our error, we have no PyDub. So we can just kind of work our way through these. Poetry add PyDub. And let's see what we get now. So it's running, which is great to see. I don't love this being called load, so while that runs and we can see it's actually transcribing, let's rename this to docs. That's pretty conventional in PyCharm, and we'll see we got an incorrect API key provided. Great. So I wonder if I just pass it in like this, if I get anything better. I doubt it. So give me 1 second and I will be right back. All right, cool. So it was just a bad naming and import. PyCharm had kind of screwed up, but I needed to open that file, so I didn't want to share it. But here we go. Running again with the import being correct. We'll see hopefully afterwards, after it transcribes the video, we get a nice transcript of, my AI 2024 predictions, which is pretty cool. Once we have those docs, we generally want to combine them, or we want to combine them into, like one set of documents. So you can see we have a document here, there's page content. These parsers can often load like multiple docs, and so I tend to see people combining them so that they can be, split or joined for the vector store. So if we just, take our docs and we, do doc.page content or doc, for doc in docs, we can kind of iterate through them and build a new list. Let's just like map out an array of only the page content. This is not so interesting because actually in this case, for this one video, we only have one document, but I think it's nice to do just as like a habit. So we can call this combine docs or something like that. And so now we're just, an array of only the page content. So that gets us out the transcript, and we don't need any of this metadata for now. We could keep that if we wanted to put that in our vector store too, but it's not generally that interesting. And so now let's get some text out of that. We'll grab all the text and we can, just join together all of our docs in this array. So assume we had a bunch of them, join. And so now we have one long string of all of the text that's coming out of these documents. So if I just like print that out, this is going to end up being slow. So we'll probably stop running it over and over again just because, or we'll memoize, in some way the document so we don't have to keep going back out to the Whisper API. It ends up being kind of expensive and just slow to test. So as that runs, we can look at, a text splitter. So see, now I have just the text form of the document. So now we need to chunk out docs. So think if this was a much longer video or I had a bunch of videos or a bunch of PDFs or something like that, I need to chunk those out so they can be stored into a vector store and then eventually searched. And the chunk size ends up being something you experiment with based on, the type of content you're working on. Also, you can work with the Whisper API. I won't do that in this video, but like you can give it a vocabulary. So it's naming our company wrong. This is Focused Labs with an ED, but we can let that slide for now since it's just a little tool. Maybe I throw that in to a later video or something like that. So if I want to do, these combined docs so that we can split them and then embed them, we're going to use, a recursive so there's a bunch of splitters that you can use. Oops. And I probably spelled it wrong or picked the wrong thing. I wish we got slightly better things or completion of unimported documents from PyCharm, but it just doesn't do it. So maybe later. So then you get like a couple of things you can play with. So you can play with a chunk size. This is how big you want like your selection of characters in this case, or however you want to tokenize and chunk up your documents, how big you want it. So I like to do, say we do like 200. So we have 200 characters, and then often in order to make sure that you don't accidentally mess up or break apart any like kind of context or really important sentences or paragraphs or something like that, you'll create a chunk overlap. And so maybe we want to overlap 50 characters. So now we have our recursive splitter, and we can actually go in and we can take this splitter and we can say splitter dot split text and then give it our text. So now if we drop down, actually pretty cool. I'm going to just keep doing this for us, even though it's a bit slow. Sorry, let's grab that whole thing and we'll say split text, and then we can go here and we can say split text. And if I run that again, what you'll see is we get our split text back out. It'll have to transcribe again. Well, that's transcribing one more time. So maybe it would be smart to memorize this, but I don't want to do that right now with y'all. Let's set up our vector DB. So I like to use the Facebook vector DB, just for local development, or Pinecone is awesome if you want to store something up in, the world. So if you notice, it split this up into a handful of chunks. You can see the chunks and how they actually have some overlap in them. So go ahead and look through that. So if I take my vector DB and I say, from text, and then I take my split text, and then I need an embedder. So that's going to actually be my OpenAI embeddings. I can do both of these things, and I'll be able to get out now a vector DB. So that vector DB allows for us to search, for embedded text and then pull it eventually back out. That's pretty simple, but I guarantee when we run this, we're going to end up with an error. So let's run it again and get our error. While we do that, let's write a fun prompt maybe. So I love kind of playing with prompts. I like the chat prompt templates. So if I take my chat prompt template and I take like from template here and I, let's write something. So there's like a generic RAG prompt, which is like similar to like, actually, let's see, what did we get here? We did get an error, no API key in our OpenAI API key. So let's just pass that in again. How does it want it? Base model and embeddings. And it looks like it can take a OpenAI client or an OpenAI API key as an argument. So let's pass in the OpenAI API key equals OpenAI API key. That should give us, hopefully, the error here, and we'll just say, go back to writing our RAG prompt. So there's normally like a really simple one, which is just like answer the questions based on the given context, and then like you pass in some context. That's what's going to come out of our vector DB, and then you give it a question, and we're going to pass in a question. Cool. That's what I was hoping for. So we don't have tick token, so let's go and install tick token for OpenAI, and then let's run it again, and we can look at our prompt. So we're still not quite to where we're embedding everything yet, but we're working on our prompt. Now, this is like a super easy generic prompt, and it works great, honestly, but I like to give it a little more juice. So like, something along the lines of you are a helpful social AI media expert. You specialize in YouTube and YouTube keywords and are in keywords. You are an expert description at writing descriptions. Let's like break line here. Descriptions, titles, and you use keywords that help with video discovery. Given you are given the transcript of a video as context, let's go, I'll break this down again. Context, go ahead and answer the questions based on the following context. I like this kind of thing because it gives it a little bit more help in like what it can do. And let's see, so we don't have our next dependency. So we can poetry add that, and hopefully let's see, what's that package called? LangChain vector stores. Not seen this before. Let's see what's going on here. I'm gonna pause and come back when I solve it. That's right, the package isn't called FAS like that, but you need to pick like either between FAS CPU or FAS GPU. So there we go, we can use FAS CPU. And that should give us everything we need. So now we've got the ability to embed in our vector DB, and we have our prompt written out. It's nice, so we get to use our chain. So let's construct one. The really cool thing about LCEL is when you construct a chain, it's just a series of pipes. Each one of these like individual components in the pipe can be parameterized and tested individually or played with or swapped out. And there's a ton of stuff you can do with them. We're not going to do any of that really here. It's just going to be a simple RAG pipeline, but there's a lot you can do, and maybe in future videos we do more. So there are two things that I need to get into my chain as input. I need, and we have these in our prompt. We need context, which is what's going to come out of our vector DB, and we of course need our question that the LLM will parse and then answer. And we'll use OpenAI's chat OpenAI as the LLM. And actually, let's just like grab that really quickly. So LLM equals chat OpenAI, and then we import it, and I'm guessing it's going to need an API key too. And it's pretty easy to either pass a client in or an API key, or have some sort of config object to make you not have to do this every time. So maybe I could have been a better steward of good code and used the OpenAI object or exported an environment variable that if you export OpenAI API key or something, it's just always there. So you don't need to pass it in and like parameter or couple everything to a global. I just thought it'd be easier and I wouldn't accidentally show off my key. So let's see. So I take my LLM, I have that. You can pass a model in too if you want, like GPT-3.5 Turbo or the 4 Turbo or whatever you want. We'll just use the default, which is 3.5 Turbo for now. One thing I really like doing is setting up a temperature. Temperature on the LLM tells it kind of how random it gets to get. If you're kind of unfamiliar, it's basic. And so what that will help you do is get more predictable or kind of the same output every time, and it won't hallucinate over your RAG, so it tends to be a little bit more accurate. So I want to start my chain by passing the question through to the prompt, as well as getting all the context I need out of the vector store. So the way we do that is we grab a question, and that's just going to come out of our thing, and we're going to pass it into a runnable pass-through. Runnable pass-through, the runnable API spec. Can I spell? Runnable pass-through. Apparently no. The runnable pass-through is, or the runnable API or interface is the interface that all parts of the chain use. So what this is saying is just like take the question key from the previous input and pass it in, and then just pass it through under the key question. So super easy. And then I need to get my context out. And so the context is not going to be a runnable pass-through. The context is actually going to go to our vector store. So if I go to our vector DB and say, as retriever, we're going to end up with a retriever that we can pass in our embedded question to, and then our embedded question will get searched through the vector DB and then pull out eventually our matching parts of our documents, or those split chunks. And you can pass some parameters in here, how many docs you want to return, or different types of searches, but we'll keep it simple for now. And then let's get rid of this warning and just call this chain. I don't like the yellow. So now we have this kind of beginning. The other way to think of this dictionary syntax is as runnable parallel. A runnable parallel is just it's the same exact thing as this, as it being represented as a dictionary, and you can either pass a dict or you can pass keyword arguments into the runnable parallel to get all the same stuff. So what we're doing is we're going to pass like something, like an invoke or something like that into, we're going to call our chain with invoke or stream or anything like that, run, and out of it we'll get some output. So actually I kind of want to show you that because it's kind of cool, and then we'll finish out the chain with an LLM. So if I do chain.invoke right away and I just say, question is, what are the predictions? And then I say like output, or just invoke is fine, and I print that for us. I can run it. We'll go through the parser again, and we'll parse our video one more time, and then we will hopefully get a response from our vector store, and it'll be a series of documents. So now what we can do is we take this runnable, if you notice here, and we can use this pipe syntax. So that's what you'll see all over like modern LangChain. Oh, what happened here? Well, let's get rid of this print because it's confusing me. And our get relevant documents is not getting the question directly, is what I think is happening. So what I need to do is I need to actually pipe in, we're passing a full dictionary into the vector DB, and it doesn't know how to search for those documents. So instead what I want to do is I want to say I want to grab like a single item out of my input. So there's two ways to get that. I can use item getter and say question, or I can use, and I can pipe that in, or I can use a lambda. So now if I run that again, and then we'll go back to writing our pipe, and hopefully it doesn't break again, I can pass that into our template. And then from our template, which is our prompt template up here, so now what's going to happen is our context key is going to get passed into that template, and our question key is going to get passed into that template. And so it's going to fill in those two things. So all those documents that come out of our vector DB and all the questions, and there you go. We now get our documents, or we get our context, and we get our documents out of there. So we can pass all that context in, and then we can pass that into our LLM. So then we can have a conversation with it. And then finally, the most important part is we need some sort of output parser. So we do a string output parser. And that output parser just helps us get well-formatted output. There's a bunch of them: XML output parser, JSON output parser. Depending on how your LLM responds, you can use different things. So now, if you notice, I asked what are the predictions, and I got some small parts of the document that the document parser thinks are, that the vector store searched for and thinks are relevant. So now I can drop that whole chain in and run this one more time. Next, we can just make this a simple program, so it's just a little nicer to use. And I like doing that just with a async main. And that way, we can ask a bunch of questions of it versus go over and over again. So here are my 4 questions parsed out of the video. That's pretty cool, right? And so now we can just kind of say grab some input from our user. So enter your question, and then grab that out and call that user input maybe. And then you could say I don't know, we can take that and we can say run the chain, or we'll say chain.stream question is going to be user input, right? So now we're going to pass that in, and now we have our we have a generator that will stream out our option, or what's coming. And then we can say for a chunk maybe in stream, which is pretty standard, we'll just print our chunk, and then after that prints all out, we can print a couple line breaks or something, and then run our program. And import that. And last try here, and we'll see how this does. Last transcription, hopefully. We're going to print out this invoke one more time. That's okay, though. And if you notice, with just 58 lines of code, I'm able to parse a local video file with the OpenAI Whisper APIs, transcribe it, give it to a RAG LLM, and then finally start asking questions of it. So let's see if this works. So I have my question here, and I can say what would a catchy title for this video be? And if you notice, my chunks are printing all on their own line, which was a mistake. And I also probably should use an async stream. So let's try this one more time. But here it is, revolutionizing AI development. Predictions and game-changing tools is the output. Sorry, this is an async, not a wait. And I always like to say, equal true. Oops. And end equal quote. empty string. Let's try one more time with this and see if we can get out, a nice response. And that should do it for our video. Let's see here. Other things you could do to kind of clean this up is better naming. Always playing with your prompt is a great thing to do. And then there are some great ways you can add chat history. So right now, like my questions, I can keep asking questions, but it has no like conversational awareness of the context that happened before. And so I can't say like, oh, tell me more about that, or, dive in. So let's try this. Let's see if it prints all on one line. And there we go. Catchy title, streamed out, nice and simply. Can you write me a nice description that thanks the audience? Thanks everyone for watching, and gives a quick pitch for Focused Labs. And there you go. Streamed out, and a nice little description. So thank you all for watching. Hopefully you learned something, and feel free to reach out to me on Twitter or X or whatever it's called, or LinkedIn, and comment on the video.